method 2 for the geometric, and I'm going to use, just that you can see it, we're going to use the probability mass function. So if x is geometric, parameter p, where I've defined x the number of trials until the first success, then what this is, it's you failed, say, x minus 1 times, and then you get your success. So that this is the probability mass function. Okay, so I'm going to do the same thing now. I'm going to prove this thing. So the same arguments before, probability of x bigger than s plus t given that probability. X is bigger than t, this is the left hand side. Let's just put it now so we can see what they're saying. Is equal to probability of x bigger than s plus t and x is bigger than t, or probability x is bigger than t. Take the top bit here, probability of x bigger than s plus t. I know I do have to repeat all this again, but I'm just doing it so that it's kind of familiar to you. Same as saying x is bigger than s plus t, so now going up slightly faster. What is probability of x plus t using the PDF? Well, it's beyond s plus t number of goes. X is discrete random variable, so it's summing, and what you want is the sum of the probability of x given x from x is equal to s plus t to however many goes, which is unlimited, so it could be infinity. So now we substitute for this guy into here, and I'm sure at this point some of you will begin to switch off the video because you say, oh no way, I'm not going to do it this way, which is perfectly fine. But in case you're interested, two terms multiplied together, two components of the term multiplied together, only one depends on x, so using the fact that p is a constant as a common factor, we can drag it out to the other side. So that's p sum s plus t q to the x plus q minus 1, sorry, q minus 1, like this. And now what? Now what is now working? We want to go back and just check whether we've done anything wrong. So we know that this is true. X is bigger than s plus t. X is discrete, so bigger than or equal to mean different things. So if I look down here, I can see that I am not summing over the right thing. Because x is bigger than s plus t, it must mean that therefore it's bigger than or equal to s plus t plus 1. So the first smallest value it can be is s plus t plus 1 plus 1 plus 1. So I hope you spotted that. Did I do it on purpose? Well, no. Let's see. So if you wanted to express this some more, you could have said for sure like t plus 1, okay? Don't need the step, but it helps to see that the smallest value of x is s plus t plus 1. Now that looks fine. Okay, well, we've got this infinite, so it's like a GP, isn't it? It's an infinite one, except for instead of starting at 0, we're starting at a point which is not 0, because we know that if this starts at 0, then it'll be of a nice form, because q is a number less than 1. We know something like this is equal to power I is 1 minus a, isn't it? So we would like to use this result, but we're not starting at 0, so we want to make a substitution for this. So what we want to say is something like let j equal, and then just take all these guys to the left hand side, x minus s minus t minus 1. So why do we do that? Because if you do that, then the smallest value that this will be, it's got to be when x is equal to that. But if x is equal to that and you take this over to the other side and subtract it, the smallest value of j will be 0. And then j will run to infinity as well, because this is x goes up in increments of 1. So if that thing is infinity, this guy isn't going to kind of control that guy, so it's still infinity. So anywhere we see x, we replace it. We kind of rearrange it. So here we have q to j, isolating x, taking st1 over to the other side, we have j plus s plus t plus 1 minus 1, because remember about that guy here, put that in brackets, so you can see that the 1's are going to cancel. So if you allow me to do that, let's just rub that out. Didn't need that step there. Okay, so this is what I have. And what can we do now? We obviously cannot get a numerical answer because we don't know what p and q's are. So where do we stop? We can see that this is the power of j plus s plus t, but which we can rewrite as, let's do it on the side because it's not real. It's something you. This is same as saying q to the j times q to the s times q to the t, or s plus t, yeah, using the kind of rules of powers of or exponents of these numbers. So what I could say is that basically we've got this q. I've split it up so that there's terms involving j which are kind of summing over, and terms which do not depend on j, constants. So that's the reason I did this step. And then the constant can come out, so we've got q s plus t, and then the sum q to the j, which I obviously now know is 1 over 1 minus q. Alright, so we could actually replace this now by 1 over 1 minus q, and then the q cancel one of those q's there. But I don't want to kind of do that because I don't think it's going to add anything. Let's then look at the bottom part of the expression of this left hand side. So we don't actually have to do anything because it's of the same shape. So this probability x is bigger than t is going to be equal to probability sum j equal to 0 q j plus t, which is equal to, I could have just done that, p q t sum of j equal to 0 q j. Right. You can see why I didn't bother to write that, because I can see a lot of these two are going to be the same, they're going to cancel. Therefore, the left hand side is, and just basically 1 divided by 2, expression 1 divided by expression 2, and you can see that's going to be qs. Let's call this star. Right, I told you there's a little more work with the PMF, probability mass function. But we've done all the hard work because now the right hand side is in a similar kind of fashion. Right hand side we want probability x is bigger than s. And just looking at the pattern, it's the same thing, so it's just p q to the s, sum from j equal to 0 to infinity q to the j, which I want this to come to q to the s, so now I do make the substitution. This is a infinite geometric progression, and it works because q is less than the value of 1. So this is going to be 1 minus q, like so, right? And then what do we say? But 1 minus q, 1 minus probability of failure is the same as probability of success. So in other words, it's the same as saying p. P's cancel. Call it double star. Star left hand side equals double star, done. Now